Okay, so today we come to lesson um, 3, separating mixtures. So we're going to continue on with that syllabus dot point, exploring the homogeneous and heterogeneous mixtures, and using some separation techniques based on physical properties. So today it's mainly about the separation techniques. I'm going to go through them with you here, and then we have a practical scheduled. If you're doing this from home, if you want to make up the practical, you'll have to talk to me about that some other time. Now, the actual, before we start, just some revision questions. So they should be at the top of page 12. Have a go at them. If you've done them, here are the answers. So, what are substances made up of a single type of atom? They're elements. The substances made up of two or more different elements chemically bonded are compounds. And mixtures are substances made up of mixing two or more other substances together, and they can be homogeneous or heterogeneous. Now, before we begin, just a little bit of more revision from year 10 or even earlier. I believe we teach this in year 7 as well. A solution is a homogeneous mixture that contains one substance, which we call the solute, and it's dissolved in a liquid, which we call the solvent. Now, the solute, so the thing that we're dissolving can be either a liquid, a solid, or a gas. So we can dissolve, for instance, sodium chloride. So salt can dissolve in water. We can dissolve, let's say, ethanol in water. That mixes in pretty well. And water can also dissolve gases like oxygen or carbon dioxide. So just remember that term solution. So it's a homogeneous mixture, and one thing's dissolved in a liquid. Now, when we're conducting experiments, chemists quite often need to separate mixtures. So we might perform an experiment, do a chemical reaction, and we want to isolate one of the products. And so we need to then be able to separate what we want from what we don't want based on its physical properties. Now, there's several techniques that we're going to be using, depending on the mixture that needs to be separated and depending on the physical properties. So we're going to do a couple of these today in a prac, and the other ones I'm going to show you, do an example of. Okay. So firstly is decanting. You might have heard this term before. So decanting is an easy separation technique for solid liquid mixtures where the solid's heavy enough to settle to the bottom of the flask. Okay, so the liquid is then carefully poured off the top of the solid. So here's a picture of it. We have what we call the sediment. So that's our solid stuff that's heavy enough to fall out of solution and fall to the bottom of um, the beaker or whatever it's contained in. And then we just simply pour the liquid off the top. So decanting something that could separate, say, rocks and water. You just pour the water off the rocks. You might use decanting when you're starting to drain your pasta, just tip the water off the top before you drain your pasta, that sort of thing. So that's decanting. The next thing we have is filtration. So filtration is just a technique that separates solids from liquids, but we don't necessarily need them to be settling out. Okay, so if we have a bit of a suspension where the particles stay in the liquid, so something like dirty water, we can just filter it out. Now this is only useful for heterogeneous mixtures where there's still a solid in the liquid. And the filter paper is set up in a filter funnel, and the mixture is then poured in. So just like that, we pour it in, and the filter paper collects the solids and allows the liquid to drain through. Okay. Now it's important with this that we flute our filter paper. I'm going to show you that in the lab later, but it's basically folding it to make sure that the filter paper isn't actually contacting the filter funnel all that much. Okay, so if there's contact between the filter paper and the filter funnel, we're actually not going to get any flow of liquid down the sides. It's all going to have to come from the tip, and it makes it very, very slow. Okay, but I'll show you that when we get to the lab. Evaporation is another one we're going to be doing today. So that's a technique that separates dissolved solids from liquids. Solutions poured into an evaporating basin, and then heat is applied until the solvent evaporates. So, for example, we could have salt in water. We just heat it until the water starts evaporating and leaves the salt behind. We can't use this one to separate liquid-liquid solutions, mainly because we don't know when it transitions from one liquid to the other. Okay, now we can, theoretically, if we had, say, I don't know, water and ethanol, you could boil off the ethanol first and get left with the water, but then at what point does it stop heating? Sorry, at what point does the evaporation stop being ethanol and start being water? Um, so we don't actually use this for liquid-liquid. It's mainly liquid-solid, because we can just keep heating it until all the liquid's gone and the solid's left. So we see on this picture here, this one's set up with a beaker. We prefer to use an evaporating basin if we got one. Which is ceramic, and it's designed for that high heat evaporating sort of thing. So we put our mixture in the a solution in the evaporating dish. We apply heat from the bottom with a Bunsen. We make sure it's on a tripod with a gauze mat and that it's on a blue flame. Okay. Now, to separate liquids, we use distillation. Okay, so distillation is a technique that separates components of a solution, but mainly liquid-liquid. So the solution is placed into a round bottom flask, heat's applied until the solvent evaporates. The vapor is then collected in a condenser, so that's a bit of glassware where we've got some cool water running through, and it cools down the vapors enough that it condenses. So it goes back to liquid phase. Techniques usually used to separate liquid-liquid solutions, however, can use it for solid-liquid, but it's not preferential. Okay. So this is a diagram of it. So we've got our round bottom flask just on the left there, with our mixture. We apply heat to the bottom of that and vapors start coming up. We have a thermometer in what we call the still head. Okay, so that's where it kind of branches off. That'll actually measure the temperature of our vapor. So if we know that something boils at, let's say 87 degrees, like ethanol, we can look at the thermometer, see that where it's, as it's boiling, it'll be sitting at 87 degrees. Once that starts to rise, we know we're starting to evaporate water, so then we can stop. Now the vapors go down to the right there into the condenser where it's a lot cooler. They condense back to liquid, and then they drip out the end into our collection vessel, which could be, here we've got a conical flask, could be just a little sample jar or whatever. And the stuff that we distill off, that's called a distillate. Now, separating funnel, you can see our separating funnel here. These are used for heterogeneous liquid-liquid mixtures. So basically where we have two liquids that don't mix. The mixtures are poured in and allowed to separate, and then the bottom layer is drained out the bottom through the stopcock. Okay, so the example they've given us here, it's water and kerosene, which don't mix. So if we ever have, a mixture of oil and water and we need to separate the water from the oil, we use one of these separating funnels. So basically we open this tap at the bottom, let that water layer out, and then we're left with the kerosene in the flask and water's drained out. Now, practical for today, what we're going to be doing. So rest of this lesson, possibly next lesson, we'll be practicing our separation techniques. It's going to be a multi-step separation where we use to separate sand copper sulfate mixture, and I'll also be showing you some distillation and some separating funnel uses. Okay, so we don't necessarily have to do that. I'm not going to get you guys to do that, but I will show you what's going on. Okay, so that's it for today, and yeah, we'll move on to the prac.